Hello, welcome to a new video. So today we're gonna look into the winner of the previous videos. We compared the latest, let's say the new or modern fast languages, and only two actually passed. Those two were D and B, these two right here. So these two actually are promising and they are both already winners. So if you want to use any of these two, I would say that's great. D is a bit longer, is older than B. So D is older than B, because it comes earlier in the alphabet. Okay, so we can compare. Let's compare them a bit more. So let's open D. Um, they are not the top 10 most popular languages, of course, but they are probably the two best, in my opinion. At least they are the two that passed my tests, right? Oh, this is not the one. So there's a problem. If this version didn't work, this is the one that works, which is learning D with DAP. Okay, so this works. Well, there was also another winner, but not for me. For those who don't use IntelliJ, so I was scoring the languages in terms of if they are good for IntelliJ. There was another that was good, but not good for IntelliJ, which is NIM. So if you don't use IntelliJ, you may want to use NIM. I use IntelliJ, so I have to choose between Dlang or Blang. Okay, so I'm supposed to show my face, but it's not being shown. So my face is here. Where is the other? Oh, yeah. This is just because it's not always on top, I guess. Okay, so this one, it says that project SDK is not set up correctly. I don't really know. Unable to find object.d in the source path or class path. I don't know what source.d is, but the plugin is not that good. The plugin of D for IntelliJ is not that good. Having said that, what's something good and kind of not that good about B, or the largest or the biggest difference between Blang and Dlang, is the syntax. So this is more a C-like syntax, which is good for some times, but sometimes it's not that great because maybe you don't want this semicolon at the end, and that's an error, you have to put it. Whereas in B, let's switch to B for a second. Blang learning. In B, you can have really, you don't have to have that semicolon at the end of each line. So that's a good thing about B. Okay, so I also have another guest here, which is ChatGPT with GPT-4. Okay, it says ChatGPT can make mistakes. Consider checking important information. Okay, so I think it's kind of fun when I use it, and it would be funnier even. Can I move the browser to these windows so that you can see me? So this is the summary of yesterday, or yesterday was it? I don't remember if it was yesterday. I think it was yesterday. This video. Okay, so let's move it here, and now you can see me. You can see the IDE, and you can see ChatGPT, which is great. So let's make me a little bit smaller. Okay, sounds good. Now, let's say, do you know about Vlang and Dlang? First question. And ChatGPT says, browsing with Bing. That sometimes it should answer without browsing, right? Sometimes it browses too much, the latest update. Because it would have produce a better, I think, response even if without using the internet. But okay, it says Vlang is a statically typed language created by Alexander Medvenikov and became open source in July 2019. It draws an inspiration from Go, is influenced by Rust, Swift, and Operon, aiming to provide a balance between familiarity and innovation. Dlang is designed to be simple, fast, and safe, suitable for developing maintainable software. It compiles itself in less than a second with zero dependencies and supports automatic C to B translation. Dlang syntax is clean and expressive, which makes it easy to grasp for developers with backgrounds in languages like C, Go, and Python. The language is compiled as a systems programming language. It emphasizes simplicity, safety, and speed. Dlang, or D, is a multi-paradigm system programming language created by Walter Bright at Digital Mars and released in 2001. Oh wow, that's a lot older, like 20 years older, with Andrei Alexandrescu joining the design and development effort in 2007. It is characterized as a general-purpose language with static typing, systems-level access, and C-like syntax. D aims to be what C++ aspired to be and is suitable for writing high-performance code that can interface directly with the operating system's API and hardware. It is well-suited for developing medium to large-scale programs and supports both systems-level and application development tasks. The language is designed to offer fast code execution and is rich in a stable specification and implementation. Okay, so from the ones that I tested yesterday, which are really the best options out there, which is this is the summary of yesterday's video, which says the losers is Zig and Crystal, because they are very, very slow to compile. Okay, if I want to use this, I may stick with something else, right? Like, I don't know, probably even Go, maybe? I don't know. So, losers. Nim. The plugin does not have anything useful to create a project or even a file. However, it compiles fast. So it's good if you don't. This is good if you don't use IntelliJ. And the winners. It says Blang, as fast to run as Dlang, but seems to have better IDE and integration, which is true, a lot better. Dlang is okay with some problems with the IDE plugin. So for the D guys, you have to improve your IDE plugin, and then you can be neck and neck with Blang. Okay, so first, second, third, fourth, and fifth. Okay. Actually, these are losers. These are not worth it, I would say, for me. I don't know, maybe for you they are, but I want something to compile fast. Only these three, and then only these two. So 2 out of 5 won. That's great. And I have more experience with B than D. Lang. It's hard to pronounce and differentiate between them. But also, on the other hand, I have more experience with C than B. And D looks like C. Okay? These one letter languages. Okay, so probably with a little, with a little training for me in D, maybe one day or two, I become better than I am in Blang, probably, because I would use my C knowledge and would be more similar to C. But well, B is also similar to Kotlin, which I also know. So all the languages I know is C, Java, Kotlin, a bit of C++ as well. Not an expert in that though. And now B, and trying kind of B, because I don't know a lot of B. I write programs, but I'm not considered. I know what I'm doing because of lots of mistakes. And now I will try to learn B and D. Okay, and I'll try to fight them, each other, to see which one is better. But I feel that both are already very, very good. But for some use cases, one may be better than the other. And that's where I want to find out and show it to you here in this channel. Okay, so yes, this I can write a bit of B now because I know a bit of this. So now let's open the browser and let's close the things that are not relevant. So B and D, I will leave them open because they are relevant. And okay, that doesn't work for me, but okay. So we close crystal. We close nim. We close this nim as well. We close nim. What's this? Nim again. Nim sig. Close sig. We close this. By the way, if you think I'm wrong, right, there's some hidden configuration to make these languages decent, let me know. But at least out of the box they're not. That's why they didn't won. Okay, so here we are, and we have these different, as far as I know, D has these kind of 3 kinds of compilers, which is, well, this is the official or the natural compiler for D. Also has this GCC based compiler and LLVM based compiler for if you need them, right? Okay, sounds good. Now we have video tutorials. So probably something better than that B has, of course, and it's obvious, is that it has more learning resources like tutorials and all that, because it's 20 years older, right? It has to have more resources for that. And yeah, so I mean, here it says that the B extension does things for you, but I don't think they did it very well, because let's see if I can write something. Okay. Let's see if I can write something in D. Okay, I'll ask ChatGPT. Okay, write a simple prime number finder in Dlang. So let's see what it does. It says, certainly, below is a simple D program that finds and prints prime numbers up to a specified limit. This example uses a basic algorithm for checking prime numbers. A number is considered prime if it has no divisors other than 1 in itself. Okay, so let's copy this code. Well, it doesn't have, I mean, ChatGPT doesn't have highlighted for D. Okay, so now let's go to the D project. Probably, can I open 2 projects at the same time? Open file or project. Where is it? Idea project. Learning B2. Oh, this is the fresh B, right? This window or new window? New window, right? Okay. Oh, let me see how this thing works. Okay, so we have these 2 things, but now I cannot switch that easily between them. Okay, anyways, maybe I'm just not good enough with these tools, but Why did I again? I opened the incorrect one. I need to open another one. So now I will test the other feature, which is open the same window. So just see what happens. D with Dov. Okay. Let's say this window. Let's see what it does. This says this window learning D with Dov. Learning B2. Oh, I have to. They are being reopened every time. Oh, I understood now what's going on. So, well, I need to select new window or whatever it is. New window. Okay. Okay, so now I go here and I can paste the code ChatGPT gave me, which is this right here. I'm gonna try to run this, and it printed. You know, this fast. That was fast. Did the same for Vlang. Okay. Here's a simple V program that implements a prime number finder similar to the Dlang version. It includes a function to check if a number is prime. Then iterates the numbers up to. Now, well, I can benchmark the languages, right? Yes, I can benchmark them. Okay, so we're gonna switch to the B project, which is this one, and I will paste this here and I will run it. Did I? Oh, I selected the debug thing. Sorry, that was my mistake. Run it again. Huh? Both are fast. I mean, that's why I choose them, right? That's why they're here, because both are fast. Okay, now what I want to do is I want to let's do benchmark kind of thing right here. Okay, so open terminal just to see what's going on, and here we will cd into bin, I guess, right? Okay, so time main, it says 0 and almost nothing took, which is kind of fine, and that's because we are using 100, which is too small of a number. And now, well, we can also invoke the compiler. So how can I do it? I should do like a building. Or can I build it here? Oh yeah, it's building down here. So the integration with that is good. So it is able to build. Okay, now I can run it here. And it's not working. Well, because it's not building the binary, I guess. So I'll run it from here. I guess that's a more direct way of doing it. And then going back to terminal. The other way is using invoking the compiler from terminal, right? Maybe that's a better thing to do. But now this is working. It says 0.0006. Okay, but this is not a great test because it's most of the time is spent printing the line. So let's see. Well, first, as I always do, if you know me, the first thing I do is the following: fnol, which means output line. And inside OL, we have a string, which is S, and this is println. I always do this. I think it's my style of coding. I don't want to say println every time, println. I just want to say OL. Thanks. That's great. Now, how can I benchmark this? Because it's printing which one is prime, right? So probably which is not really great, because I want, because what I'm trying to say, well, if I don't print this, then maybe the compiler figures out a way to not calculate it as an optimization, thinking I don't want it, but I want to measure it, the time it takes for that. So I need to, well, use that somehow. So probably, what if I learn here and say store all primes in an array? I wanted to store the prime numbers on an array. Please do it for both languages. Okay. Let's see if it's able to do this. Sure, I'll modify both examples to store the prime numbers in an array before printing them. Okay. First, here's the Dlang version. So we'll use that later. Okay. Well, this is more familiar to C. If you know C, well, this looks almost like C. I mean, exactly like C, I would say, except for this right ln, but and this here, but then it looks pretty much like C. So this is testing lots of interesting things. Actually, it will test how good is it for creating these. What's going on? Some noise in my neighborhood. Okay. So it will test how good it is for allocating memory, how it is for calculating, how good is all this. Okay, so let's copy this main function, because I'm guessing the isPrime thing will not be like modified, right? Would be the same. So we only update the main function. Of course, it says println, which we don't like. We like OL instead. I don't like. Okay, so prime numbers up to whatever. Okay, isPrime, put it here and then print. Okay, let's see how long it takes. So for simplicity and for later purposes as well, I will invoke the compiler from here. So say b dot. Cannot use in a string as a string. Can you? Oh, sorry. So I have to use. What do I have to use? Probably this notation. Will that be enough? I don't think that will be good enough. Well, the linter is not saying anything about that. So it's not, they are not super duper supported, but I should have specified the name, the output name, main. So I say main, and it shows this, which is kind of cool. It's also easy to print, so it figures the way to print this, which is great. I mean, in C, that would be a headache just to print that, I guess. And now I want to time it. Okay, so it takes 003, which is okay. It's not enough data, so 10,000. But then it will print 10,000, which is, I mean, it's not bad, because it's printing only one time, so one system call, which is not bad. So I forgot I have to compile. As you can see, it's very fast compiling. It's immediate. Oh, here we go. Okay, now we're gonna increase the stakes a bit, 100,000, right? Because we're testing fast languages, so they should be able to do more than slow languages, right? Oh, this takes a while. Yeah, but this is not really what we want. We don't want to spend most of our time printing to the screen. Of course, that's not the kind of benchmark we want. We want something different. We do want to print, but we will create a loop here, so we can print for, I would say, for prime in primes. Is that thing. Can I do that here? Yeah, I guess I can. So say if prime modulus 10 equals 0, which means it's a multiple of 10, we will print it. Okay, this is better and will reduce by 10 times what it took to print it. If that's not enough, then we can increase that to a bigger number. Unnecessary. Oh, you don't need this parenthesis in B, by the way. Thanks, compiler, for telling me. Now, oh, it still takes a lot. So we'll have to do by 100 or 1000, probably 1000. Oh, I'm missing something. I'm kind of missing something. I'm doing it wrong, or why it's taking too long to print this. Well, all of these are that, but 20,000. This is a bit of an odd behavior. Am I doing something wrong? That shouldn't be that many, right? I mean, yes, this is not correct. Maybe I'm doing something wrong. I don't know. Should I put this between parentheses? I'll ask ChatGPT. The following code is intended to, it's in Vlang, to print only numbers that are divisible by 20,000, but it is not working, and it is printing lots of numbers when numbers even if they are not multiple of 20,000. Oh, box here, box there, box bunny. This issue with your Vlang code is that the expression does not check for divisibility correctly. In B, most C languages, the multiplier returns the remainder. The remainder will be 0. If the number is divided divisible, the technician should check if the remainder is equal to 0 to verify. But that's what I'm doing. That's what I'm doing. Oh, it's effectively checking. Remember, there is not 0. But here I was doing it with the other way. It still didn't work. So okay, let's do it again. Just to check that I'm right. Okay. It's still not working. So maybe Blang, is this a bug in Blang? So let's try to debug Blang to see if the okay. this is not what I mean. Okay, so I will log what's going on. Okay, so remainder will be set to prime modulus 20,000, right? And then I will print what the remainder is. Remainder. Okay, and now here we can simplify this into remainder. And now, and also, oh, I'm sorry. I'm doing something wrong here. This is my mistake, sorry guys. I am printing primes, all primes here. So that's my mistake, sorry. So yeah, no number is really it's no number is really a multiple of 20,000, right? So yeah, it's printing the remainder. That's fine. I say if the remainder is equals to zero, then print the prime. So yeah, my mistake so far, but it's not there. So 2000 probably. No, it cannot be 2000, right? Because it wouldn't be a prime, right? Right? I guess. I mean, okay. Okay, so divisible by 17, let's say. But that's not the case. Oh, well, I'm feeling stupid now. The reason that they are primes is that they are not divisible by anyone by themselves. Holy cow. Okay. So how I need something different to do than this. And that would be to how would I do this? To divide them? To see if they end in some number, for example. That could be some interesting thing to do. For example, and of course that will be not we'll be doing lots of extra work, but that's fine because we're benchmarking things. And I'll say str at 0, which begins. Okay, I will only print those which begin with how can I do this? Begins, I mean first character. So here I will say first digit. You have to use underscores and lowercase. First digit. I'm still laughing about my mistake in trying to divide prime numbers. Okay. I'll create another variable here, which it's not bar. It's called str or prime str, and I will assign that to prime str. And here I'm sorry. So here and first digit I will do prime str at 0. Okay, and then and last digit I will do prime str at, can I say last? Do we have last? Only last index. Okay, I will say prime str len -1. That means our last index, right? That would be better, I guess. Last index. Okay, so I will only print the primes that have the following, that start. We'll have lots of 9s here, right? So, or I can do something even better here. I can transform this to an int. Can I do it to an int? Can I say int? Can I do like u whatever? I think I cannot do this, so can I do something like this? Int? I think that's the way you do it in B, right? Oh yeah. Sounds good. Okay, so great. So now we have extracted the first and the last digits. Maybe there's a mathematical way to do it faster, but okay, that's fine. This actually benchmarks even more things, right? Memory management and all that, creation and using of memory, whatever. Okay, so when I will print a prime, I will only print a prime if the first digit, now it's not a prime. The first digit is not a prime, so I can actually divide it by 2, for example, or modulus 2. Let's say if modulus 2 is 0, okay, and if last digit cannot be modulus even, right, because it's a prime. Modulus 3 is 0. So with this amazing new check that I've created, I'll try to do this again. And something's wrong. A non-integer string index fn prime str last index non-integer string index fn. What the hell? What's this? This has to be called in this way. I will just do len -1. Will that work? Yes. Okay, now it worked. This is what I wanted. Okay, something that doesn't spend too much time in printing. It's printing a digit that's even, and the last has to be multiple of 3. It works. Okay. So Vlang is fine. I was wrong. Okay, so now if I time it, we have 41 milliseconds. That's fine. And then here, probably I can do like 7. Will be faster, and 1 million. 1 million. Okay, 1 million. This is a test. I guess it will take a while, right? No, it's fast. So 523 seconds. So can we go fast? Can we do better? Yeah, and still it's not that bad. Is it optimizing something? I don't know. Because it's okay. Or I can do something else, right? I can add like all the primes, like say, for example, sum, or I don't know, say 0, right? And here I will print sum, right? I'm printing sum, and here I can add all of them, right? I don't need this and this. I don't even need this anymore. So I can say sum plus equals prime. But of course, the Dlang will not let me do that because sum is not immutable. Because immutable by default. So I say mute, and then I can do that. And the sum is a negative. The sum is too big. So 0L, will that make in the long? Apparently not. Can I say like U64 Okay. Okay, U64 0. Will that be a thing? Yes, it is. So here it all will be U64. Will that be okay? I guess. So we're doing big things. That's why we need U64. Okay. Oh, what's here? Can I depend int to this? Oh, can I depend int? Okay. Where is that? This is line 33. Right here. A number is an int. And so I have to do U64. Will that be okay? Will that fix the problem? I don't know, the first thing. It's 4. Oh, it's prime. Also needs to receive an U64 number. I like the U64 and U32 notation. I like that. And here again, U64. Well, we're testing lots of things about the language here. Unexpected things. I didn't know I was going to be testing with. Okay, it says module prime, B test prime is imported but never used. What? Okay. Maybe it imported thinking I would use it. So here we have the result. That's the sum. That's the result of the program. Now let's see how long it takes to get that result. It takes not too much. So I will increase these takes, right? 10 million. That's 10 million, right? 10 million. That's a lot. Okay, how long would it take? Maybe that's too long. That's too much? Maybe that's too much. It's not actually. It's done. 6 seconds. Okay, now we have something to test. Now we have something we can benchmark Dlang against. Okay, so I won't write this in Dlang, right? I will just ask ChatGPT to do it. Translate the following program to Dlang. Okay. So exciting. Which one was gonna be faster? I don't know. Let's see. And of course, Blang can be faster if you set the production flag. But the downside of that is that it takes longer to compile. So which is okay, because only when you're going to go production you set it on. Otherwise you compile fast. In the provided B program can be translated, blah 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 blah. Okay. Let's see if ChatGPT translated it correctly or not. Okay, so we'll copy this code. Then we're gonna go to our D project. Okay. See how this divided to 10 million. Can I do that in Vlang? Oh, we don't know. We'll test that later. But now let's see if it compiles first of all. Running. So it's running. And it has a result. The result is 32 million whatever. Okay, so that's fine. I want to benchmark it, right? Oh, it's okay. So it compiles right here. So I would say time learning with dub. Okay. Let's see how long does it take. 5 seconds. So it was faster than B. Okay. There's a couple things. So 5, that's 6 seconds. 32, 0, 33. Let's see if that's the case with B. Is it generating the same output? We don't know. So let's see. 32, 0, 33. So both are generating the same output. Okay, so now, well, I want to test this little thing if I can do this syntax thing in Vlang. Oh, apparently yes. So I can do that. Okay, now there is a way of two ways that I know to improve B performance. So the first is to say cc and then equals to clang, for example. Sorry for the noise. I live near a fire department, whatever. This is not how you do it. I always forget how this is done. Sorry. Probably it's just like this. Yeah, that's the syntax. Okay, it takes like 1 second longer to compile. But now let's see if it's faster. So previously it was 6.3. Dlang, for comparison, let's say how this is okay, 5.6 can be with Clang beat 5.6, 5.69. Let's see. Well, let's see. Okay, 5.6 is the score to beat. Will it be faster? No, it won't. Okay. So B is being faster, but there is a last like chance. Well, let's see if we can do it with GCC, and then we also have the last chance. This is not the last chance, but let's just test if GCC works. So with Clang is 6.6. With GCC it's 6.3. Okay, so GCC a bit faster. Okay. Now well, the production flag, which is optimizations, right? Turns on optimizations. Let's see. Dot o main. I guess that's correct. So it takes a lot longer to compile. So it's fine if you just want to, I mean, go. Oh, it's done. It's done. It's not that much longer. It's there. It depends on your program, of course, but for this not very large program, it didn't take that much time. Let's see if it can beat 5.6. 5.2. So it beats Dlang. But of course, I have to test Dlang with optimization as well. Otherwise, it would be an unjust fight. How to compile Dlang with optimization enabled. Okay. To compile Dlang for with optimization enabled using the DMD digital Mars D, using the release. This is optimization already code. Additionally, this is the release. Disable checks typically are okay. So it says additionally you can use the release flag to disable runtime checks, which are typically enabled during the debugging phase but can be turned off for release build to potentially increase performance. Here you can compile it with optimization. Inline. Oh, okay. This has some things that I want to try, of course. Let's try the first flag by its own, -0. And also we will check how long it takes to compile, right? So we can find a sweet spot. In B, I knew these flags, but in Dlang, I don't know. So the score to beat is 5.2 seconds. Can D with optimization do better than that? Well, we'll see. 5.2 seconds. Will 5.2 seconds. Will D beat that? We don't know. Okay, so I guess I can say DMD -0 and say, oh, it's not well, I was have to say source app. Is that correct? After D -0 main. Will that do it? Oh no, supported. Oh, okay, so it's off. Uh, main.d. I didn't told you to do main.d. It's app.d. Okay. Well, for practical purpose, let's get into source. Okay, now we have this app.d. Gonna find main.d. So app. Okay, it compiles fast. So time app 5.2 was 5.2 was the record, I guess it was 5.5. But it has more flags. The other flag is release. So let's compile with the release flag. Very fast. Now let's see how long it takes. 5.5. Almost the same. Not very good. Inline. Still not beating B. Release. Inline. Okay. Five point 4. So, well, it's not like beating all that. Oh, okay. So now if you have the LDC, you can do more things. Do I have LDC? I don't think I have LDC. How to install LDC? I'm just trying to see if it can beat Vlang. And maybe it can with this. Maybe not. Who knows? Use an installer, use a chocolate. Chocolate. Why? Let's do this one, right? LDC. Front end. Is this what I'm talking about? Or is yes, it is. Or it's just ChatGPT hallucinating. Okay, it's it. Okay, Linux x86-64. Well, it's big, 67 megabytes. Well, let's see. Okay, I don't know how to install it. Maybe ChatGPT already told me. Download. Follow the installation instructions to verify the Blaze name location that's included in your path environment variable. Oh, can I install using this? I don't know. I don't think I can do that. Is it apt? Let's see. Yes. Okay. Well, that's great. Points for Dlang. Well, because older. Because it's older than B. It already is in the repositories of Debian. Okay, so now I have LDC. I don't, but maybe because I need to open another terminal. LDC. Still not. Do I have it here? LDC. Still not. How do I access it then? Sudo LDC? I don't know. Is that the way of accessing? Type in LDC. LDC2. Oh, LDC2. Oh, now we're talking. Okay. Okay. So we're still alive. LDC2. And now let's see what... for even more aggressive optimizations, you can consider using the bound checks off option to disable random check-ins, although this can be dangerous because of such correctness. Well, it doesn't rely on that. So let's just, before moving to LDC2, check this. I mean, I won't encourage to do this, but still interesting to check and to test because we're testing here, right? So we will put this bound checking off. Time up. Will it even improve the score? I don't know. Yeah, 50 milliseconds. Well, not bad. Okay, now we will test LDC2 with all these flags at once and on app.d. Well, 2 seconds. Oh, that's a lot less. Well, that's a lot less. Yes. Okay. Oh, this, I mean, I guess this is an optimization. What it should be doing here is that it's not calculating all the items. It figures out which items I will use later, and it will calculate. I don't know what it's doing. I mean, I'm just speculating. And I don't know enough about compilers to figure that out by myself, so I don't know how to do that. But 2 seconds was a great improvement, okay? And for Vlang, what would be a similar comment like this for Vlang? So I guess I only know the production flag, but I don't know the prod flag. I say, however, you could use the prod flag for optimization. Then here it is. Okay, yeah. So the best optimization that B can do allows it to run in 4.2 seconds. I guess it was right. What's for the 5 for the 6? 5.2. Sorry, 5.2 seconds is what B takes to run this with the prod flag. And it actually takes a while to compile, right? So it kind of takes a while to compile. However, my favorite way of compiling in B is not that, is probably something like this. And then it takes, let's see how long it takes. It was fast compilation, and it takes 6.2. Well, it's not the fastest, but both are very, very fast. I mean, other languages will take like twice as long or something. And these are, we're comparing fast versus fast. So so D here would be the winner in terms of especially with this compilation with LDC2, because it only takes 2.8 seconds, which is great. And of course, let's delete bounce checks off just to see how long it takes. I mean, the same, which is kind of cool. So far, the most powerful compiling command is this one, LDC2, O3, all that. and it's quite cool, and it's quite fast as well to run. But with the DMD, which is the official compiler, it takes 5.4 seconds with all these things. 5.4, so I would say they are comparable and they do not disappoint. That's the main thing. They do not disappoint. And 5.4 seconds on the D side, and 5.3 seconds, or sorry, 6.2 seconds with some fast compilation. If we go slow compilation, B goes down to 5.3 and D goes down to 2, but I think that's doing some tricks, right? But still, without tricks, D without tricks, D fast compilation without tricks, B fast compilation without tricks is 5.3. Okay, and now D fast compilation without tricks is 5.4. So 5.3, 5.4. And in 10 million numbers, that's great. They're neck and neck. They're fast. They're fast. Okay, so this is like round 1 of B versus D. Okay, so let's write it down. Let's save this like 5 languages compared, which is the previous video. And now we're gonna do a new one. Dlang versus Vlang. Round number 1. Result is a tie. What we measured: performance in compiling and running prime number finders. Okay. Advantages of Vlang we saw here. Of Vlang, and that would be better IDE integration, and advantages of Dlang. C-like syntax and fast compilation. I mean, they are great. Both are great. I'm happy with both. I have to say that I'm happy with both. The syntax, well, it's not that hard here, but if we can compare it with D, then it says MIILLION. So I actually prefer U64. Oh, yes, I guess. Yeah. Yes, so well, this is more like C. So for each it's not separated. It's okay, it's one word for each. Okay. 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 Well, it says Project ACK not set up correctly, so I don't know how to set up correctly. If you know, tell me. And also this unsolved import, well, again, is because it's not set up correctly. I mean, yeah, am I missing something? Probably, but I don't know what I'm missing. This is Java things. The SDK default, maybe that will do it. I don't know. SDK. So for probably here is what I need to fix. Is there being DMD? Right? Oh, DMD. Well, is that correct? I don't know what I'm doing. I think it's still not. Okay, I don't know. So, better integration, Vlang wins. But these not that bad, I mean. Yeah. So yeah, that's the result. If you want to see me doing something that you think it's important to do in these languages, let me know and I'll try to do it in a future video. So I think that's it for this day. Thank you for watching. It's almost the same as yesterday in length, which is great. And bye. Have a great day.